Hello, my name is Aaron Beichelbeck, and I want to present to you an approach on how to integrate interactive static software performance analysis into the IDE. A problem that static analysis tools often face is that the results are presented in separate interfaces and not directly in the IDE. And this can lead to unwanted effects, like for example requiring the developer to split their attention between the IDE and another interface, which can be an inconvenience. So we integrated static performance analysis data into the IDE itself with both interactivity and traceability of the performance data in mind. More concretely, we developed an extension for the editor/IDE Visual Studio Code that integrates the performance data provided by the static analysis tool Infer developed by Facebook. The performance data is presented to the developer via function annotations using VSCode's so-called code lenses that we're going to see in a second. We also use editor decorations, like for example coloring of function names, to provide intuitive feedback on the code's performance. Additionally, side panel views can be opened by clicking on the code lenses, providing overviews and more details of the performance data. This is what the extension looks like in action. We have two different code lenses above each function. One that gives us the cost of the function in big O notation as provided by Infer, and another one that opens an overview of the costs of all the functions in this file. Let's look at the detail view for this function first by clicking on this code lens, where we can see the exact cost of this function as calculated by Infer in addition to the big O notation. And we can also see a trace that provides an explanation on how Infer arrived at this particular cost. We can also see that the function names are colored differently depending on the cost. In this case, this function has quadratic cost, so it is red, and this function has linear cost, so it is yellow. Now let's see if we can make the cost of this matches indices function any better. Without going into much detail about what's happening here in the code, the reason why the function is this expensive is this loop right here, together with the call to the simple match function, which has linear cost. Right now, this function takes a string array as an argument. So let's see if we can simply make it less expensive by giving it the entire string instead of the split version of the string. This means we are also going to remove this loop right here and change the call to this matcher function accordingly. Of course, we also have to change the call to the simple match function now, giving it this index string instead of an array. Now that I've saved the file, we get this warning up here that the cost of the function might have changed. This is because the call to the simple match function now takes different arguments than before. And down here, this simple match function has no more performance data available, because we changed the parameters of it, which makes the extension recognize it as a different method than before. In order to receive fresh performance data, let us re-execute Infer and see what happens. We can immediately see that the costs for both of these functions have been updated. This function is now constant, and this one is now linear, so we improved the costs for both of the functions. In addition, new information has been inserted that shows us how the cost has changed from the last analysis to the most recent one. Thanks for watching this brief demonstration of our tool.